Ever thought you'd explode if exposed to space without a suit? Well, think again. Contrary to popular belief, your body wouldn't go boom in the vacuum of space. Instead, a more accurate term for what happens is decompression. It's a bit like what divers experience when they ascend too quickly from deep waters. The reduced pressure causes the gases dissolved in your body fluids to come out of solution, forming bubbles. In space, this would happen almost instantly. Your skin and blood vessels would balloon out, but they wouldn't burst. You'd puff up, sure, but you wouldn't explode. And here's another surprise. You could survive this, albeit briefly. A human can actually live for about 15 seconds in space without protection before losing consciousness. So, while it's not exactly a walk in the park, the reality is less Hollywood and more science. So, no dramatic explosion, but space is still not a place you'd want to hang out unprotected. Imagine the roar of a spacecraft in space. Now, erase that thought. It's a common misconception that sound travels in space, but the reality is quite different. Space, being a vacuum, lacks the medium, like air or water, that sound waves need to propagate. Think about it, when you hear a spacecraft in movies, it's usually accompanied by a thunderous roar or a high-pitched whine. But in the vacuum of space, there are no air molecules to carry these sound waves. Let's take the example of the International Space Station. If you were floating next to it as it hurtles around the Earth at over 17,000 miles per hour, you wouldn't hear a thing. Not a whisper, not a hum. The only sounds you'd hear would be those transmitted through whatever you're in physical contact with, like your spacesuit or the spacecraft itself. So in space, no one can hear your spacecraft zoom. A solid sun? Not quite. Picture this, instead of a solid sphere, the sun is a giant glowing ball of gas. Yes, gas. Comprised mainly of hydrogen and helium, the sun is not solid but a continuous state of fluid motion. It's like the bubbling pot of soup on your stove, constantly roiling and churning. The sun's incredible heat and pressure cause these gases to undergo nuclear fusion. In this process, hydrogen atoms combine to form helium, releasing an enormous amount of energy. This energy is what lights up the sun and provides Earth with warmth and light. The sun's surface, or photosphere, is also not solid. It's a layer of gas about 300 miles thick that emits the sunlight we see. Above this layer is the sun's outer atmosphere, or corona, which extends millions of miles into space. So, the sun isn't a solid but a fiery ball of gas and plasma. Meteor showers, spectacular and dangerous? Let's set the record straight. These brilliant light shows in the sky have sparked fear in some, leading to the misconception that they pose a significant threat to our planet. But let's debunk this myth right now. The truth is, meteor showers are composed of tiny fragments of dust and rock that burn up in our atmosphere, creating those streaks of light we love to watch. They're incredibly small, often no larger than a grain of sand, and they're fast but not fast enough to make it through Earth's protective shield. Our atmosphere is remarkably good at protecting us. It ensures that the majority of these space particles burn up long before they reach the ground. So, despite their fiery appearance, meteor showers are far from dangerous. They're a harmless, beautiful display of nature's fireworks. So, enjoy the next meteor shower without fear. It's a safe spectacle. The Big Bang, an explosion? Not in the way you might think. Let's clear up a common misconception. The term Big Bang might conjure up images of a colossal detonation, but that's not quite accurate. The Big Bang was not an explosion that occurred at a single point in space and time. Instead, it was the moment when the universe, as we know it, began to expand. Picture this. Rather than an explosion, think of the Big Bang as an inflation, a sudden stretching of the universe from an incredibly hot and dense state. This expansion happened everywhere at once and is still underway today, which is why we observe distant galaxies moving away from us in all directions. So, when we talk about the Big Bang, we're not talking about a cosmic firecracker, we're talking about a rapid, universe-wide expansion, an event that set the stage for everything we see in the cosmos today. So, the Big Bang wasn't an explosion, but a grand expansion. Black holes, gateways to another universe, it's time for some facts. We've all seen the movie scenes, the brave spaceship, hurtling into the swirling, inky abyss of a black hole, only to emerge in another dimension or a distant part of the universe. It's a captivating idea, isn't it? But how accurate is it? In reality, black holes are not gateways, but regions of extreme gravitational collapse. They're formed when a large star burns out its fuel and collapses under its own gravity, creating a point in space where gravity is so strong that nothing, not even light, can escape. This intense gravity warps the fabric of space and time around it, but it doesn't create a tunnel to another universe. While the laws of physics as we understand them don't entirely rule out the possibility of wormholes, these are not the same as black holes. They're purely theoretical and, so far, remain unobserved. So, black holes aren't wormholes, but they are fascinating windows into extreme physics. The moon made of cheese? A tasty myth, but let's slice into the truth. This whimsical idea can be traced back to a simple parable from the Middle Ages. The story tells of a simpleton who sees the reflection of the moon in a well and mistakes it for a round cheese wheel. While it's a charming tale, it's quite far from reality. The real moon, our only natural satellite, is a celestial body composed primarily of rock and dust. It's a barren landscape with countless craters, mountains, and valleys, shaped by billions of years of meteor impacts and geological activity. Its surface is covered in a layer of fine dust, known as lunar regolith, which is a mix of tiny glass beads and sharp, jagged pieces of rock. So while it might not make a great topping for your cracker, the moon's geological composition is a fascinating topic of study. So the moon isn't a wheel of cheese, but it is a fascinating world of rock and dust.